Hi guys, welcome to this set of videos. What we're going to do here in this set of videos is we're going to continue with this idea of similar triangles and using the proportions that we can set up dealing with similar triangles to help us solve problems. And in fact, this might be my favorite section because it is kind of tied to an interesting sort of memory that I have. I had a grandfather who was a physics teacher, and one of the neat things about physics teachers is they often do a field trip where the field trip is to an amusement park. Physics teachers love applying physics to amusement park rides. Well, I'd always been a pretty big fan of roller coasters, and one time he let me go with he and his physics class to the amusement park, and of course his students are all working like crazy the whole day to try and figure out the problems about the rides, while he and I just got to enjoy the rides. Anyway, we're standing in line at one point, and I was quite a bit younger, 14, 15 maybe at this point, and I loved riding roller coasters, but I was obsessed with the height of the highest hill. I wanted to ride the tallest, fastest roller coasters. I loved the thrill of it. So anyway, we're standing in line at one point for a roller coaster, and I'm looking up at this massive first hill, so excited to go on the ride, and I said to my grandfather, who was a physics teacher, "Man, I wonder how high that is," right? And of course, there's no way that I can measure it, right? We're not going to bust out a ruler or a meter stick, walk over and measure the height of this hill. That's just not practical. But being an amazing physics teacher, what he did is essentially he explained this, what we're about to do right now, as a way of indirectly measuring the height or the distance of something that you can't measure by conventional means. And from that point forward, I was hooked. I wanted to know as much as I could possibly know. So I'm really excited about this section. Let's just jump into it. What we're going to do is I want to know how we can use similar triangles to solve problems, but that's no different than what we've essentially been doing for several sections here. Here's what's going to happen. We're going to use the proportional relationships to do an indirect measurement of objects. What this means, an indirect measurement simply means that we're going to be dealing with objects that you cannot measure by conventional means. You can't pull out a ruler or a meter stick and just go measure it because of physical limitations or not being right if you're trying to measure the distance across a gorge or the distance across the canyon, right, or the distance across a river and you don't have a boat. Right? How can you measure those distances if you can't physically lay down a ruler or a meter stick and measure the way across? Now, of course, if you've got one of those little laser range finders or something like that, okay, great, use the technology. Today, we're doing the geometry. Here we go. So what we're going to do is an indirect measurement. Here's the way the indirect measurement is going to work. Oh, I'm sorry, I want yellow. There we go. Involves using the properties of similar triangles to measure the heights or distances that are either too great or too difficult to be measured by conventional means like using a ruler or a meter stick. And I have a fantastic problem for us to get started here. Since we're here in sunny Orlando, Florida, let's measure the height of a palm tree. Shall we? We shall. In fact, let's go ahead and color that palm tree. Let's make it green because it's nice and green outside and we like green stuff. Yay, there we go. There's a green palm tree. Okay, now what we're going to do is the way that this works is you're actually going to use shadows. Okay, you're going to use an object that you can access and the shadow that it creates at a certain point of day due to the sun. Please keep in mind, if I go outside at a certain point of day, that tree, that palm tree, will be casting a shadow. This right here represents the shadow of the tree. So that means the sun is somewhere right up in here-ish. There's my sun right there shining nice and bright. I've got this little ray of sunshine coming right down through here, casting the shadow of that tree on the ground. What we're going to do is either take myself or a meter stick or a ruler if I have one. I'm going to plant that meter, in this case a meter stick, right there. Once again, that meter stick is going to cast a shadow. Here's the sun. That meter stick, because of that ray of sunshine, that ray of sunlight, is going to cast a shadow on the ground. The question is, how? How can I use this to help me? Well, here's where it comes in. These triangles are similar. Let me show you. Triangle A, B, C is proportional to triangle X, Y, Z. Right, so triangle ABC is proportional to XYZ. Let me show you how. We have several theorems to prove triangles are proportional. Let's see which one works for us in this case. Please notice, right, that we are going, we're going to assume, right, it works, of course, better if you're on level ground. In fact, let's be on level ground. So as long as you're on level ground, right, either yourself, your meter stick, and the tree are going to form a 90-degree angle with the ground. So that one is a given. That one right there is sort of our given. It's a perpendicular 90-degree angle, which means angle B is congruent to angle Y. So you want to make sure that you're on level ground so that you are perpendicular to the ground, perpendicular to the shadow that is created by the ray of sun. Okay, well now I just need one more angle. And of course that extra angle, that additional angle is going to come from right here, right? The idea is this, right? As long as you take the measurements at the exact same time of day, the position of the sun is going to be the same in both cases, right? In both cases, the sun's in the same spot. Measure the shadow of the tree, measure your shadow or the shadow of the meter stick, right? And the angle at which the rays of the sun are hitting you is going to be the same in both cases, as long as those measurements are taken at the same time. So, angle X, angle A is going to be congruent to angle X. And there you go, that's enough, right? Go back a couple of sections. We learned the angle, triangle, similarity theorem. That's it. According to the triangle similarity theorem, all I have to do is show that two of the angles in the triangles are congruent, and I know that those triangles are similar. And we just did. I have two angles that are congruent in each of these cases. I know that those triangles have to be similar, so we can set up proportions. Let's do that. I know, thanks to the triangle similarity theorem, I know that YZ has to be proportional to XY. And because the triangles are similar, this ratio, the ratio in this triangle, has to be equal to the exact same ratio in this triangle. Well, YZ, that's BC. And XY, that's AB, or in this case, what we will call the height of the tree. It's H. We're going to plug in what we know and solve for H. 1.6 divided by 1 is equal to 7.2 over H. Alright guys, here you go. It's a proportion. We're going to solve these the exact same way that we've been doing them here for the last several sections. I got to get that H out of the denominator, cross multiply, only the cross multiplication is super easy because 1 times 7.2 is 7.2. So I will have 1.6 H is equal to 7.2. Divide the 1.6 to the other side. 7.2 divided by 1.6. Don't fat finger something on your calculator and you will get 4.5 meters. What is the height of the tree? The height of the tree is 4.5 meters. So even if you don't have a ladder, or any sort of easy way of measuring the height of that tree, no problem. If you can measure its shadow and then use some other object, yourself or a meter stick or something like that, as to create another similar triangle, a little bit of geometry, and you can calculate the height of something indirectly by another means. All right, head on over to the next page of the notes. We'll try a few more of these together. I'll meet you there.